Good day, sir. I am Giannis Buhat, BSHM2G. The topic I've chosen is the Fibonacci numbers in the golden section. Who was the Fibonacci? Their full name was Leonardo Pisano, born in Pisa, Italy in 1175 AD. Grew up with the North African education under the Moors. Traveled extensively around the Mediterranean coast. Met with many merchants and learned their system of arithmetic. Realized the advantages of the Hindu-Arabic system. Fibonacci's mathematical contributions. Number 1. Introduce the Hindu-Arabic number system into Europe. Number 2. Based on the 10 digits and a decimal point. Number 3. Europe previously used the Roman number system. Number 4. Consisted of Roman numerals. Number 5. Persuaded mathematicians to use the Hindu-Arabic number system. And it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Fibonacci's mathematical contributions continue. Number 1 is wrote 5 mathematical works. Second, 4 books and 1 preserved letter. Third, Liber Abaci, the book of calculating written in 1202. Second is Practical Geometry written in 1220. Next is Flos written in 1225. And next is Liber Quadratorum, the book of squares written in 1225. And the last is a letter to Master Theodorus written around 1225. The Fibonacci numbers were introduced in the book of calculating. Series begin with 0 and 1. Next number is found by adding the last two numbers together. Number obtained is the next number in the series. Pattern is repeated over and over. For example is 0 and 1. 0 plus 1 equals 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. And 3 plus 5 equals 8. And 5 plus 8 equals 13 and so on. The formula that we are used is F open and close parenthesis n plus 2 equals F open and close parenthesis n plus 1 plus Fn. So we have examples of Fibonacci numbers in nature. For example, is the spiral. To get the next shape of the spirals, you need to add the previous shapes to get the next shapes. The example is banana and pineapples. Because banana have 3 or 5 flats and the pineapples have a Fibonacci spirals in sets of 8, 13, and 21. The golden section in the Fibonacci numbers. The Fibonacci numbers arise from the golden section. The graph shows a line whose gradient is P. First point close to the line is 0 and 1. Second point close to the line is 1 and 2. Third point close to the line is 2 and 3. Fourth point close to the line is 3 and 5. The coordinates are successive Fibonacci numbers. The golden section in geometry is the ratio of the side of regular pentagon to its diagonal. The diagonals cut each other with the golden ratio. Pentagram describes a star which forms parts of many flags. For example, is the Pentagon and the European Union and United States flags. The golden section and the Fibonacci numbers continued. The golden section arises from the Fibonacci numbers obtained by taking the ratio of successive terms in the Fibonacci series. Limit is the positive root of quadratic equation and it's called the golden section. The golden proportion is the basis of the golden rectangle, whose sides are in golden proportion to each other. The golden rectangle is considered the most visually pleasing of all rectangles. For this reason, as well as its practically, it is used extensively in all kinds of design or architecture, advertising and packaging, and engineering, and can therefore be found readily in everyday objects. Quick look at the rectangular shape on each side. Choose the one figure on each slide feel has the most appealing dimensions. Make note of this choice. Make this choice quickly without thinking long or hard about it. Group 1, A, B, C. Group 2, D, E, F, G, H. What was special about these special rectangles? Clearly, it is not their size, it was their proportions. The rectangles C and D were probably the rectangles chosen as having the most pleasing shapes. Measure the lengths of the sides of these rectangles. Calculate the ratio of the length of the longer side to the length of the shorter side of each rectangles. Was it approximately 1.6? The ratio approximates the famous golden ratio of the ancient Greeks. These special rectangles are called golden rectangles because the ratio of the length of the longer side to the length of the shorter side is the golden ratio. Golden rectangles can be found in the shape of playing cards without book covers, file cards, ancient buildings, and modern skyscrapers. Many artists have incorporated the golden rectangle into their works because of aesthetic appeal. It is believed by some researchers that classical Greek sculptures of the human body were proportioned, so that the ratio of the total height to the height of the navel was the golden ratio. For example is the Paternon because of their balanced proportion. And an example is the Egypt pyramid in Egypt. And last is the us. We have a perfect proportion. So sir, thank you po. This is my report in Fibonacci numbers in the golden section. This is the end of my report. Thank you, sir.